Most of us think we know the ocean. We swim in it. We cross it in ships. We look at it from beaches and cliffs and feel a sense of familiarity. But that feeling comes from a very thin slice of reality, the surface. Because once you start going down, the ocean becomes something else entirely. Hidden beneath the waves is a world humans were never meant to see. A place where sunlight fades, pressure rises, and life reshapes itself in ways that feel almost impossible. As we descend, the ocean changes in layers. Each one feels like a new planet, governed by different rules. At the top, everything feels alive and energetic. Sunlight pours into the water, powering plankton blooms that spread like invisible forests. These tiny organisms feed small fish, which feed larger fish, which support entire food webs. From coral reefs to the largest whales ever to exist. This is the ocean most of us recognize. But light is fragile. By the time you sink below about 200 meters, sunlight begins to weaken. Colors disappear one by one. Reds vanish first, then oranges and yellows, until only blue remains. Eventually, even that fades. Photosynthesis stops here. No plants can grow. No sunlight-driven energy enters the system. This is where the ocean begins to feel unfamiliar. Welcome to the twilight zone. An enormous layer of water stretching down nearly a kilometer. It's not fully dark, but it's dim enough that survival becomes a constant challenge. There are no forests here, no grass, no algae. Instead, life depends on what drifts down from above. Tiny particles fall continuously through the water. Waste, broken cells, the remains of dead organisms. Scientists call this slow, constant snowfall marine snow. To us, it looks insignificant. To the creatures living here, it's the foundation of everything. Where food exists, life follows, but not in ways we easily recognize. Many animals in the twilight zone are almost completely transparent. Their bodies resemble glass. Organs are barely visible. Muscles are thin. Pigment disappears entirely. The glass squid drifts through the water like a ghost, its internal organs floating in plain view. The glass octopus is so clear that only its eyes give it away. Why transparency evolved so often remains a mystery. It may help animals avoid predators in low light, or it may conserve energy in a place where producing pigment simply costs too much. Other creatures take a very different approach. Instead of hiding, they glow. In the deep ocean, many animals generate their own light through a chemical reaction known as bioluminescence. To us, it looks beautiful. Blinking dots, glowing patterns, soft pulses of blue and green drifting through the dark. But here, light isn't decoration. It's survival. Some animals use light to lure prey closer. Others flash signals to find mates. And some use light to disappear. From below, predators can spot silhouettes against the faint glow coming from the surface. To counter this, animals like the firefly squid line their undersides with light-producing organs. They carefully adjust their brightness to match the light above them, erasing their shadow. Their outline dissolves. This technique is called counter-illumination, camouflage made not from darkness, but from imitation. Some species play even stranger tricks with light. The bloody belly comb jelly produces a deep red glow. In these depths, red light doesn't travel, making the jelly appear completely black. Any glowing prey inside its stomach remains hidden, invisible to predators that might otherwise notice it. In a world shaped by darkness, visibility becomes everything. Who can be seen and who cannot determines survival. But the twilight zone isn't just strange, it's dynamic. Every night, as darkness spreads near the surface, something extraordinary happens. Billions of animals begin to rise. Lanternfish, squid, jellyfish. An entire hidden world descends together to feed on plankton under the cover of night. By morning, they sink back down into the shadows. This daily movement is known as diel vertical migration, and it's the largest synchronized migration on Earth, larger than all herds, flocks, and swarms on land combined. For a long time, humans didn't even know it existed. During World War II, naval sonar operators detected something strange, a false seabed that rose at night and sank during the day. It wasn't rock. It was life. Below the twilight zone, sunlight disappears completely. Now you enter the midnight zone, stretching from 1 kilometer down to nearly 4. There is no dawn here, no dusk, just permanent darkness. Temperatures hover just above freezing. Pressure reaches hundreds of times what we experience at the surface. At first glance, it seems completely uninhabitable. And yet, this is where evolution becomes most inventive. Some fish wear ultra-black skin that absorbs nearly all light, making them almost invisible even under submarine spotlights. Others produce bioluminescence in colors no one else can see. The dragonfish, for example, emits red light, a wavelength that doesn't travel far in deep water. To most animals, it's invisible. But the dragonfish's eyes are adapted to see it. It has effectively created a private flashlight, illuminating prey without revealing itself. Then there are the anglerfish. The females dangle glowing lures in front of their mouths, attracting prey in the darkness. But their reproductive strategy is even more extreme. Males are born tiny and fragile, with a single goal: find a female in a vast, empty ocean. When one succeeds, he bites onto her body and permanently fuses with her. His organs slowly dissolve until he becomes little more than a living pouch of sperm, sustained by her bloodstream. It's one of the most extreme reproductive adaptations known. Not all life here hunts. Some animals survive by waiting. When a whale dies and sinks to the deep, its body becomes a feast that can last decades. Sharks arrive first, then hagfish and amphipods. Later, bone-eating worms called osedacs colonize the skeleton, feeding on the oils trapped inside. An entire ecosystem can grow from a single body. Below 4 kilometers, the seafloor flattens into endless plains of mud. These abyssal plains cover more than half of Earth's surface, more area than all forests, grasslands, and deserts combined. And yet, they remain among the least explored places on the planet. Life here moves slowly. Food is scarce. Many animals grow larger than their shallow water relatives, a phenomenon known as deep-sea gigantism. Giant isopods crawl across the seabed. Amphipods grow larger than a human hand. Even colossal squid may roam these depths. Why gigantism occurs remains unclear. Energy efficiency, cold temperatures, and predator avoidance have all been proposed. The truth is, we don't know. Time itself seems to slow down here. Some creatures may live for centuries. The Greenland shark, known to inhabit these depths, can live over 400 years, the longest lifespan of any vertebrate. And still, life persists in every grain of sediment. Microbes recycle nutrients, sustaining food webs we are only beginning to understand. Beyond the abyss lies the deepest frontier of all. Ocean trenches, massive scars where Earth's crust sinks into itself, plunge down to nearly 11,000 meters. This is the Hadal Zone, named after the underworld. If Mount Everest were dropped into the Mariana Trench, its peak would still lie more than a mile underwater. Pressure here exceeds 1,000 times that of the surface. Temperatures hover near freezing. Survival seems impossible. Yet life thrives. Snailfish live at these depths, delicate and translucent, with flexible skeletons and pressure-resistant chemistry. They are the deepest living vertebrates known. Amphipods swarm trench floors in huge numbers. Shockingly, plastic fibers have been found inside their bodies. proof that human impact reaches even the deepest places on Earth. Along trench walls, hydrothermal vents release chemical-rich fluids from the planet's crust. Here, microbes form the base of ecosystems powered not by sunlight, but by chemistry. Entire communities depend on these pioneers. These discoveries raise a powerful question. If life can thrive here, in darkness, cold, and crushing pressure, could it exist elsewhere? Icy moons like Europa and Enceladus hide oceans beneath their surfaces, warmed by internal heat. Studying Earth's deepest waters may offer clues to alien oceans beyond our planet. Despite everything we've learned, more than 80% of the ocean remains unexplored. Each expedition reveals species never seen before, creatures that glow, vanish, stretch, and bend the rules of biology. Even among known animals, mysteries remain. Why does bioluminescence appear in nearly 3/4 of deep-sea life? Why do some species grow enormous while others become nearly invisible? For now, these questions remain unanswered. And perhaps that's part of the wonder. The deep ocean reminds us that Earth is still full of secrets, places where evolution continues to experiment, unseen. Secrets worth protecting, and secrets worth discovering.